Persistently storing data in Flutter is not one of the easiest experiences if you are just starting out. If you want to move beyond the simple preferences, which are only key value pairs which are not really sortable or queryable, you are probably looking at a library like SQFLite. The problem with this library is that it's very low level, and maybe you really do not need to use the structured SQL data. What about NoSQL in Flutter then? Well, in this tutorial you are going to learn about SEMBAST, which stands for Simple Embedded Application Store, which is a powerful but yet simple to use library for storing, querying, ordering, paginating and even encrypting data on Flutter as NoSQL stored data. Hello, welcome to ResoCoder. In this tutorial you are going to learn how to use the SEMBAST library on this project where we are gonna build a fruit app which will simply display a list of fruits which are gonna be randomly generated here. So we can add fruits which are random, then we can also update fruits here, we can delete fruits. So we have all of the basic CRUD operation, which stands for create, read, update and delete. We can do all of that in this project. So let's get right onto it. First, we need to import packages for the SEMBAST library and also for the BLoC library, because we are gonna use BLoC pattern for state management. If you are not yet familiar with BLoC, you do not need to know a lot about it, because I'm going to explain most of the really important stuff as we go, and actually BLoC pattern is not all that hard because we are gonna use a library. But if you wanna learn more about BLoC pattern and about the BLoC library in depth, you can check out the video from the card in the corner. First, we wanna go to pub.dartlang.org and search for SEMBAST, and link is also in the video description. And let's go to the installing tab, and we wanna copy SEMBAST here. Then we also want to have path provider package and also the Flutter BLoC package, but you don't need to search for them manually because you can also check out the fully written tutorial on resocoder.com. Link is in the video description, and over there you can just copy the code from the written tutorial. So no need to search for those packages manually. To import packages, we want to go to pubspec.yaml. And over in dependencies, we want to paste all of those packages in there. So we'll just copy them from the post, and they are SEMBAST, path provider, Flutter BLoC, and equatable. Now save this pubspec YAML, and now let's move on to building the database layer. For that, we are going to create a new folder under the lib folder, and let's call it data. And under data, we want to have a first class, which will be called appdatabase.dart. This appdatabase file will hold a single class called appdatabase, and this appdatabase class will hold the database logic, more precisely the database opening logic, because like with most libraries which are used for databases, we need to open the SEMBAST database so that it can communicate with a file on the persistent storage, because a database is really just a file stored inside the file system, and then the library can write data to it, to that file, and get data from that file. It can query that file, order data from that file, but really it's just a file stored somewhere on the device. So we need to open the stream through which the data will be gotten or written to that file, and that's called opening a database. So SEMBAST is no different, and we need to open the database before we can really use it. The thing with opening a database is that it needs to happen only once, and for that reason, appdatabase class will be a singleton, which means that there will be only one instance of this appdatabase present at any given moment. Let's also first import all of the packages which we will need for the appdatabase class to function properly. Again, you can check out the fully detailed written tutorial from resocoder.com, link is in the video description. First, to make the singleton happen, we are going to make a private constructor which will allow us to create instances of appdatabase only from within the database class itself, because with singleton we do not want to just simply instantiate appdatabase classes all over the place in other classes. We just want to be able to instantiate app database class within this precise class. The reason for that is that we are going to have a singleton instance here, which is a static final property of type, or actually a field of type app database. So it's the same type as the class which contains this field. It's called singleton, it's private, and immediately as soon as the class is instantiated, we want to set this singleton field to be equal to app database instance. And actually, this is the instance which is the only single one present in the entire app, because we have set the constructor to be private, and this is the only place where we are going to invoke this private constructor. Then, because this singleton is a private field, we want to create a singleton accessor which will be public. This is so that we can only get the singleton instance, but we cannot reset the singleton instance to be, for example, null from somewhere else. That's why this singleton field is private and not public. Because of that, we need to provide also a public getter. Then, for opening the database, we are going to use a completer. Completer is used for transforming synchronous code into asynchronous code, and it basically holds futures, which we will get to in just a little while. Now we can access the singleton instance from other classes by using this getter instance, but we are still not in any way or form opening the actual SEMBAST database. First, we are going to add an accessor called database, which is similar to the accessor for the singleton instance, but here in the database accessor, we are returning a future from it, which will contain the actual SEMBAST database instance, not app database. This is just our own custom container. From here, we want to return the actual database, which is the SEMBAST database, which is the actual NoSQL database. Inside of this database getter, we first want to check if our DB open completer is null, which will be true by default, because DB open completer, whenever the app database class is instantiated, it will be null because nothing is set to it by default here. If it is null, we want to set it to be a new instance of completer here, and then we want to call open database, which will complete the completer with database instance. So how will that thing look like? Here is the open database function which will be called. It's also asynchronous and it returns future because that's what you always want to return from asynchronous functions. Although you can return void also, but it's just a good practice to always return a future whenever the function is asynchronous. That's because then you can await it if you really want to, like this. But we do not want to await this function, but anyway, it should return a future for that reason. So this open database will first get hold of the app document directory, which is called on the package path provider, get application documents directory. This is simply the platform specific directory where persistent app data can be stored. Then to this persistent app data path, we want to join a name for our database file, which in our case is simply demo.db. It doesn't really matter which kind of a name and a suffix of the file you use here. And then we want to actually open the SEMBAST database by calling open database on database factory IO. This is an asynchronous operation, so we want to await it. And then we store the resulting already opened database, SEMBAST database, inside this final database variable. Now here comes the part where completer is crucial here. We want to call complete on DB open completer. This means that any code awaiting the completer's future will now start executing. I've said previously that completers store futures. Now, how does that look like? Well, as with any other future, you can await a future. Just like we await the open database future here with this await keyword, we can also await the DB open completer's future from some other place in code, which we will do in just a while, like this. So future, right? And we want to await this future. And now whenever this db openCompleter.complete is called with the database instance, the future will complete. So any code looking like this, which awaits the completer's future, will begin executing with this precise database instance, which we have passed inside the completer. So that's why I've said that completers are used for transforming synchronous code into asynchronous code. And now you might be wondering why we have not just used a simple function which will always return the future from opening a database. Well, the reason for that is that we want to open the database only once. If we were to call database factory io.openDatabase 2 times, it would open database 2 times. And we do not want to have 2 open database instances. We just want to have 1 database instance. That's after all why we have set this app database to be a singleton, right? So we cannot really call open database function 2 times. We need to store the future and wait till the database is opened for the first time, then return whatever was returned from opening the database afterwards. But then on subsequent call, which will want to get the database instance here, we want to return the already opened database instance, not open a new instance. And db openCompleter fulfills our needs just precisely because completers can store futures, as I'm probably telling you for the 3rd time already. And then the most important step here is that we want to return the db openCompleter.future from the database getter. If this does not make complete sense now, I completely feel you. It did not make sense to me either the first time that I've try to work with this kind of code. So really just check out the written tutorial from the link in the video description on resocoder.com, and over there you can get through it at your own pace and really understand every single bit of this code. So again, how will this code be executed? Well, we will call appdatabase.instance from somewhere, which will get us the singleton instance of this class. From this instance of the class, we can call the database accessor here, and that database accessor will either open a new database or return the already opened database, because as I'm writing here, if the database is already opened, awaiting the future will happen instantly because it's already finished. That future is not really a future now, it's already done. Otherwise, if we are just opening the database for the first time, the returned future will take some time until complete is called on the completer in open database right here. Alright, so this was probably the toughest part. What will come next will be really much more simple. We want to create the fruit model class, which will hold the fruit name and whether or not the fruit is sweet and so on. So let's create the new file called fruit.dart under data. And first let's write the import statements. We want to import meta.dart, which will be used for some annotations in the constructor. The class will be called fruit and it will hold string name and then whether or not the fruit is actually sweet. And we want to be able to set up these 2 fields of this class right from the constructor, and they will be named parameters and they will be required. So that's why we need to import the meta.dart package, because required annotation comes from this meta.dart. Then we also want to have an ID, which is a field which will be not present in the constructor. And that's because IDs will be gotten from the database. IDs are automatically generated inside the database and they are unique for every stored fruit. So if we want to get just one fruit, or we want to update or delete just one fruit, we can supply its ID to the database, and the database will simply figure out which fruit needs to be, for example, deleted, and it will delete only that single fruit. Then SEMBAST stores data as JSON strings, so that's the reason why we need to have a way to convert fruit objects to maps. Maps can be then simply taken and converted to JSON strings very simply. That will be actually done by the SEMBAST package itself. We need to just convert fruits to maps, and then JSON conversion will be handled in different kind of code, which we will now write. So the first conversion function is called toMap, which will simply return a map literal here containing name and its suite fields as key value pairs. And then we also want to be able to convert from map, so map string dynamic, because we have string and also boolean as the values, so it needs to be of type dynamic, and it will simply return fruit, which will get the values from the map. So we have the fruit class, which is our data model. Then we also have app database class, which is the low-level class which is used for opening the database. But we also need to have a way to actually store and retrieve the data from the database. Objects for operating with data are by convention called data access objects. So let's create a data access object right now. We are going to create a separate file for that. It's gonna be called fruit DAO, because DAO is a shorthand for data access object. And data access objects are used to insert, update, delete, and also get the data from the database. What will be going on inside the DAO? Well, we first need to import multiple packages, SEMBAST and also our app database and fruit.dart files. And then the fruit DAO class will first need to get hold of the so-called store. Also, we need to provide a name for the store. We will store it inside a constant. So fruit store name is the constant's name. Stores are used by SEMBAST to actually store the data persistently inside the storage. This is a store with integer keys and map string dynamic values. As you can see here, this is a store factory base, which has int keys and values are of type map string dynamic. You can think of stores as of some kind of folders on the persistent storage inside that demo.db file, which we have set up here. So this file contains stores, which are like persistent maps, and the values of those maps are fruit objects. Now inside fruit.dao we will need to get hold of the app database instance, and because it's Singleton, it's really easy to get the instance and also the database, the SEMBAST database instance actually, because all we need to do is to await app database.instance.database, which is the SEMBAST database getter on our Singleton app database instance, and we are creating this shorthand get only private property called db, just so that we do not need to write this long line of code everywhere where we want to get the database instance, but we can just simply write db, which is much more short. Then the first function which we will actually have in fruit.dao will be for inserting the data. We will want to insert fruit inside the fruit store. You can add new things to the fruit store by simply calling add, and whenever you add something to the store, you also need to specify the database client, which is nothing else than our SEMBAST database here. And then you also want to specify what you want to add to the store, which is the fruit passed into this function insert, converted to map. Similarly to insert, we also want to have an update function, which will also receive a fruit, but here we need to do some more setup. We need to specify which fruit precisely we want to update. And we want to update the fruit with a specified ID, which we can get from the passed in fruit object. So for filtering, we use finder, on which we specify a filter, and we want to filter by key, and that key is our fruit's ID. Then to update the fruit, we need to call fruitstore.update. And we want to, again, specify the database instance. We want to specify the new value of the fruit, which will be there after the update. And then also the finder, which will let the SEMBAST library know which fruit precisely we want to update. And as we have specified here, the fruit with a certain ID will be updated. Very similar to update is a function called delete, Over here we also want to filter by key of the fruit ID, but instead of update, we just call delete and that's it. We do not need to obviously pass in a new value because we are just deleting, we are not updating anything, so there is no place for a new value. The final and the most interesting function of them all is getAllSorted by name. This will return a future containing a list of fruits. Finder objects can also be used to sort the data based on some fields which that data has. In our case, we want to specify a sort order for the name field. This means that our fruit objects will be sorted by the name alphabetically when we get them from the database. Then to get all of the fruits from the database, we need to call fruitStore.find and specify the database instance again and also finder. And obviously, if you were to specify a filter inside this finder also, so filter will be equal to filter.something. So for example, again, what we can do here, for example, equals, and where name is equal to, for example, banana. Doing this would cause the find function on the fruit store to return only fruits which are called banana. But since we do not have any kind of filter here, the find function will simply return every single fruit present inside the fruit store. The finder will be then used only for the sorting. But calling find does not return a list of fruits. It returns record snapshots. So we need to convert those record snapshots into a list of fruits. That can be done by using the map function, which comes with Dart, and it can be called on any kind of a list. Map functions are used for converting a list of a certain type to a list of another type. This higher order function gets every single element which is present inside that list, which is of type record snapshot. Let's just call it snapshot. We want to get this snapshot's value, which is the map of string dynamic. And as you can probably remember, we can convert maps of string dynamic to fruit objects by calling fruit.fromMap and passing in the map over to the function. Once we have the fruit converted from map, we want to also set up its ID from snapshot's key. Because snapshot key is the fruit ID, which is uniquely generated for every single fruit inside the fruit store. Finally, from this map function, we want to return the setup fruit. Then because map functions return just iterables, we want to convert this iterable to a list, and this list will be returned from the whole getAllSortedByName function. With FruitDAO done, we can move on to other layers of our app, which will be the state management layer, or actually the UI layer, because state management is basically part of the UI. You always want to use some sort of a state management in your projects because you do not want to tightly couple your UI with, for example, SEMBAST database here. While in this tutorial we are surely not going to move away from SEMBAST, in your project it's more than expected that sooner or later you will perform some drastic changes to how your app is wired up, and you might want to store data on a remote server, for example. For this reason, we need to add a middleman between the UI and the model layer, and we are going to do it in the form of BLoC, which is arguably the best state management currently present for Flutter, and it also has awesome libraries. And also, if you want to check out BLoC in more detail, I have a separate tutorial which goes really in depth, so check it out from the card in the corner. In short, BLoC is like a box which takes in events and outputs state. Events and states are simply normal objects, and as soon as the event gets inside the proverbial box, a function runs inside the BLoC where we can determine which state we want to output. So for example, if the BLoC receives an event called load fruits, we will simply output fruits loading state so that the UI can display a loading indicator, and then once the fruits are asynchronously gotten from the database by calling getAllSortedByName function on the fruit DAO from the BLoC. The BLoC will emit another state called fruitsLoaded, which will also hold the list of gotten fruits. And based on those emitted states, the UI will update accordingly to display a loading indicator or the list view with fruits and so on. For BLoC, we want to create 3 files, but thankfully we do not need to create those files manually. We can also get an extension, so just search for BLoC here. Inside VS Code, you want to download the BLoC from Felix Angelov here, so just download that extension for VS Code, and with this extension you can just simply click on the lib folder, right click actually, you wanna select BLoC, new BLoC, let's call it fruit, and hit enter. We do want to use equatable, so select yes from this pop-up, and now we have successfully generated BLoC. First, let's rename this BLoC folder to say fruit BLoC, just so that it's more descriptive. And we have 4, but basically only 3 files in here, because one is the so-called export file, which just exports those 3 different files. So we have fruit BLoC, fruit event, and fruit state. Let's first edit fruit event.dart. Because this is not a tutorial about BLoC, but about the SEMBAST library, I'm just going to paste in the full code and not go step by step. Also, as I've said, you can check out the full written tutorial from resocoder.com, link is in the video description, where there will be the full code which you can read, and also you can get the project files on GitHub from that resocoder.com post, so you can learn at your own pace from those resources. We will have 4 fruit events: load fruits, add random fruit, and then update with random fruit and delete fruit, where update with random fruit and delete fruit will also hold one final field called updated fruit and just fruit of type fruit. That's because for updating and for deleting a fruit, we need to pass in a fruit object to the fruit DAO's functions. So again, events are passed into the BLoC. And now let's move on to state. States are passed out of the BLoC, and we will have only 2 states, fruits loading and then fruits loaded. Fruits loaded will hold the list of fruits returned from fruit DAO's function called getAllSortedByName. And the fruits loading does not hold anything, it will just indicate to the UI that it should display a loading indicator instead of the list of fruits. Finally, we have the fruit BLoC. Fruit BLoC is where the actual logic will happen. Inside the fruit BLoC, we have an initial state, and even when the app starts, we want to display the loading indicator right off the bat. So that's why initial state is set to fruit's loading state. We also get hold of fruit DAO inside fruit BLoC. In more complicated app, you would also use dependency injection. For example, Kiwi is an awesome package for dependency injection on Flutter, but here we can just simply instantiate the fruit DAO directly inside fruit BLoC, because we're just building a simple little application without any kind of testing. So that's why we can do instantiation directly here. And then we're getting to the core of the BLoC, which is map event to state function. This is where the actual logic is located. We want to first check for the event which is coming into the BLoC. So if we should load fruits, as is indicated by the event, we first want to emit, so we use the yield keyword to emit fruit's loading state. That will cause the UI to display the loading indicator. And then we want to call reload fruits. Reload fruits is simply a function which will yield fruit's loaded state with the fruits inside of it. And the fruits are gotten from nowhere else than fruit DAO by calling getAllSortedByName. So we first want to return fruits loading to display the loading indicator, and then return the actual fruits which are gotten from fruit DAO. Then we also have another event called add random fruit. Here we just want to insert the random fruit to the DAO, and random fruits are, by the way, just generated from this fruits list, and we get a random fruit by accessing a random index inside this fruit list by calling random.nextInt to generate a random integer. But as opposed to load fruits, when we are adding new random fruit, we do not want to yield fruits loading because we do not want to display the loading indicator. We just want to display the updated list of fruits without any kind of loading indicator displayed in between as we are inserting the new fruit into the database. Then another event is update with random fruit. So we generate the new fruit by calling random fruit generator get random fruit. The new fruit's ID, and this is really important, needs to remain the same as the updated fruit's ID, because the IDs should not change in between updates, because after all we want to update the fruit with a precise ID, and then again reload fruits so that we get the updated fruits from the database. And finally delete fruit, we just called fruitDAO.delete, and we want to delete the specified fruit from the event, and then again reload fruit so that we do not longer display the deleted fruit inside the list in UI. Alright, once we have that, we can move on to the actual widgets to make the UI happen. We first want to go to main.dart, and over there we just want to delete the default app and make it much shorter. What we want to do here is basically just wrap the material app inside a BLoC provider, and BLoC provider can be used to access fruit block everywhere because BLoC provider is an inherited widget, so it works just like, for example, theme. We can access the theme anywhere, we can access the scaffold anywhere in Flutter. The same goes with BLoC provider. Whenever you wrap something which inherits inherited widget, you can get it from any widget down the widget tree. Also for BLoC provider, we need to specify its block, which in our case will be fruit block. And then we want to build the final UI, which will be present inside homepage, which is a file which we need to create directly under the lib folder. So let's call it homepage.dart. And again, this is not a tutorial on building UI, so we're just going to quickly get through this UI, and also you can, as always, check out the written tutorial from the link in the video description. So inside init state, we want to obtain the block from the BLoC provider, which is specified in main.dart. And as soon as init state runs, so as soon as this widget is initialized, we want to dispatch an event to the block. So in other words, we want to pass the event inside the box, the proverbial box, where the event will be processed, and then the state will be output. So right off the bat, we want to start loading fruits from the database, and then we have a build function. What's important here is this floating action button, which will dispatch add random fruit event to our fruit block. And then also we want to build body, and inside the build body function, we return BLoC builder. BLoC builder is used for listening to the state stream of the block, in our case, fruit block. And whenever there is a new state emitted from the block, the builder function runs. Inside the builder function, we obtain the build context and what's important, fruit state. Here we want to check if state is fruit loading, we want to display the circular progress indicator. Otherwise, if the state is fruits loaded, we want to display list view builder, in which we will have a list style. And what's also important here is that we want to have a trailing on this list style, which will display update and delete buttons. And these update and delete buttons are icon buttons, which call fruitBlock.dispatch, and we dispatch update with random fruit event and then delete fruit event. Now let's run the app. And as you can see, we are in a brand new clean app, which doesn't have any fruits inside the database. But as soon as we hit this floating action button, a fruit will be added to the database. We can then update this fruit to some other value. So for example, pear, banana, lemon, and so on. We can add other fruits too. So let's add multiple of them so that we can scroll through this list view. Then we can update these fruits again and we can delete fruits. So that's about it. Don't forget to check out the written tutorial from the link in the video description, which is gonna take you to resocoder.com. And if this tutorial helped you, be sure to give it a like and also share it. If you do not want to miss more tutorials like this one, definitely subscribe to this channel and also join the notification squad by hitting the bell button so that you are going to be notified about every new video that I upload, because here on ResoCoder I am determined to provide you with the best app development tutorials out there. Leave a comment if you have anything to say, follow me on Instagram, Facebook and Twitter, and see you in the next video.